Okay. Lastly, I want to introduce Reza Jelveh, the founder of SoftSage Solution OU and the maintainer of several open source libraries. Reza is going to talk about machine learning in industrial mining. Okay, let us welcome Reza.
大家好，因为这个 project 在蒙古，我有机会来台湾认识这个国家的环境 ，but the rest will be in English. So, 2 years ago, I didn't know anything about seismology. Last year, I went to Mongolia. I worked on one of the biggest gold and copper deposits in the world. Built an earthquake detection system, 地震角次软体. It's about 180 sensors right now, and it's going to grow. It's about a terabyte of data an hour, so not that big. There's limited internet connectivity. Because of that, I came to Taiwan. I have some code that is an MPlayer. MPlayer is kind of dead now. All the code moved to, interesting code moved to FFmpeg. There's some QEMU, KVM. I was a maintainer in Ansible for a while for a component, exotic component. So I go through the background a little bit, like on seismology, how the data is processed, the machine learning aspect of it, and the challenges and the open source part of it. So I don't know how many of you know about earthquakes, but basically everything is measured with 2 different waves that travel through the earth. One of them is like a pressure forward. One of them is basically sideways against the movement to the forward movement. You can actually see this is from our interface. The blue, can you? Like the front is it's ordered by velocity. The blue one is the P wave, the pressure wave that moves forward, and the other one is the slower one. And one of them is noise because it doesn't record correctly. So what is the human problem? The humans actually right now, originally, the system would identify something that could be an event, send it to South Africa, then people would go through their students, and then pick manually those selections and decide what kind of event it is. So that's of course slow and it's error prone. So why is deep learning good for this? Because the waves that you saw earlier, you can all connect them in a spectrogram. Spectrograms are also used for deep learning in voice recognition. So basically it's a similar problem, and everywhere where you can have images describing the problem, you can use deep learning to do it. So the automated version, because we have limited time, basically is a hybrid cloud solution, because most of the processing has to happen because of the speed of the internet connection has to happen on site. So there's a Kubernetes cluster on site where the sensor data goes to the central collection storage is actually taken out in a fashion that you can ask me in detail later. And it's located in the data where a potential event could happen. That's going through a binary classification first, saying like, okay, is this noise or is it an event? And then it goes to a multi-class between, is it, for example, a controlled explosion? Is it natural occurring? Is it other things? And then with that information, you can then influence the mining, you can influence the structure, you can do other things with it. One of the caveats when building streaming applications, you will see a lot of frameworks allowing you to do streaming machine learning problem solutions. You might not need them. This is a thing I will, just as a short information, one of the things you always want to do is you actually want to benchmark your code, because as beautiful as your architecture might be, you might not need any of it, and it might actually not solve any of your performance problems that you have when you do a real-time system that processes this kind of data. Yes, so go over this again. So what about open source in seismology? Most of the open source in seismology is actually, a lot of it came out of universities in the US and Central Europe. One of the most popular libraries that is used for almost everything is actually called OpSpy. So it's used in the industry, it's used in universities, it's used in like research labs across the globe. Almost all the data formats in seismology are actually in XML, which makes certain things very complex, and it comes with a lot of other caveats with the use of OpSpy, because it actually has unpredictable behavior in the way it is built. So we built a lot of wrappers around it, and it's actually, we try to make it so that the outcomes are actually predictable. The things that are very complex about actually building, we're not open source yet, we're working on it. The things that are very challenging about actually building an open source library that is meant for public consumption is that the structuring of the library, the parts that are not in, like, that have to stay in the company. The classifier, for example, is supposed to be open source. So structuring the libraries that they work independently, making it so that someone can just access the stuff, run it, and immediately get results and immediately see things that are happening. That is something we're working on. Like, of course, then comes the documentation, then comes the outreach to industry and academia for buy-in, so that people will actually have an incentive to use this and maintain this and help it being developed. And then the internal politics of how to actually get an organization like Rio Tinto, which is the second largest mining corporation in the world, and that doesn't do open source, to actually open source this is a challenge. And so I get to the call to action. So if you have experience with open sourcing this kind of stuff, not necessarily for machine learning, any kind of other open source library from a company that traditionally doesn't have a background in that, then I would love to talk to you, and I would love to get input in how to convince leadership to accept what we actually are in the process of doing. If you want a longer version of the talk, you want to talk about the seismology of it a bit more, about the actual classification, or if you can help me get to know a little bit more about Taiwan's tech community, I would be very grateful. So just as a, one of the people that made this all happen is Jean-Philippe Mercier, who was also, he's a fantastic seismologist. Philip Days was his PhD student. He created some of those location algorithms that are actually used to detect if an event happens. Ibrahim is I think he was also in mining. He's an electrical engineer, and he did a lot of the classification work. And that's it. So if you want to reach out to me, that's my line, my GitHub. And thank you.
Yeah. The first question, we are very sorry about the time because of the slots. And where is the next, the full talk next week? Can you just share it, or do we need to sign up for the talk somewhere?
Well, if people are interested, please drop me a note, and then I'll try to organize it. But anywhere, but if someone also has an idea, wants to organize it in a specific setting or a user group or whatever, also happy to hear.
Will you stay in Taiwan for a longer period?
Yes,
or?
I just got my work permit last week. Yes.
That's cool. Yeah, let me. Okay, we have a community space in Taipei, so maybe we can just have you in the community space to give a full talk.
Cool.
Yeah, I will just reach you later.
Thank you.
有没有任何人有问题想要问的？ Is there any questions for the speakers? Okay. Okay. So please just reach if you have any questions or interested in the further topics and discussions.
Thank you.
Have you met the people at Open Cultural Foundations? They are like the
好，那非常谢谢大家今天参加 AI 开源轨的议程。那现在的时间应该是在那个就是在另外那边综合大楼那边有最后的闪电秀。那欢迎大家也可以去看闪电秀，是每年 COSCUP 最后的重头戏。好的，那今天非常谢谢大家。